of the notes. Number 1, describe the motion of a falling rock when it's dropped from rest. Assume that there's no air resistance. Here we go. This is your opportunity to get a softball answer to look how smart you are. What happens to a falling object when you drop it when there's no air resistance? Maxon.
It falls.
Nice. And does it fall at a constant rate? Does it slow down? Does it speed up? What happens to it? Yes, it speeds up. Good. Everyone's like, I think it's that. I hope I don't say the wrong thing. Yes, it speeds up. So describe the motion of a rock when it's dropped from rest. So it falls, increases speed, due to gravity. And I think most of you will remember the value for gravity is 9.8. Yep. So that means that the rate at which the objects fall is 9.8 meters per second squared. Perfect. Off to a rip-roaring start. So does the acceleration of said rock change if you include air resistance? And if it does, how does it change? Wesley, what do you think? So let's start with this. Does the acceleration change?
I believe it would.
Yes. So the acceleration due to gravity, that is only true if there's no air resistance. If there is air resistance, it's not this value. So does it change? Yes. All right, Wesley, sticking with you. How do you think it changes?
I believe it would decrease.
Yeah, it decreases. If you want to find out what it is, it's very easy to do that. So if here's my object, okay, falling because of gravity. If you know what the force of gravity is, say it's 300 newtons. If you know what the air resistance force is, or drag, whatever you want to call it, let's say that that force is 250. Okay? You just do F equals ma. So 300 minus 250 equals the mass times the acceleration. If you know the mass of the object, you can figure out what the acceleration is. So it's actually, that part is not complicated. It's just Newton's second law like we've done. Good. So what is air resistance and what causes it? So air resistance is a resistance force, to motion through a fluid. And the fluid in question is air. But the reason I say fluid instead of just straight up air, the term is technically drag, and drag is for any fluid. Fluids, in case you did not know, fluids are gases and liquids. Fluids are not, and plasmas technically. Fluids are not solids. Okay, fluids are not solids. Anything else is a fluid. What causes it is friction between fluid and object particles. I mentioned last time with the lab, I kind of think of this as air friction. That's why it's air. It is literally friction. It's just friction through the fluid. Okay? And that's actually going to help us in this next part. So before we go too much further, any questions on 1 through 3? That's kind of setting up the story. Yeah?
Read where it says number 3 what friction is.
It's a resistance force to motion through a fluid, and the fluid is air. And this is friction between fluid and object particles. Yeah, that doesn't look all that legible, does it? Fluid looks like lobster almost. There you go. Did I write all the letters in the right order? I did write them in. Sometimes my dyslexia gets in the way, and then all of a sudden I just start writing random words that nobody knows. And it's like, what? It's the right. Oh, no, they're backwards. Okay, never mind. All right. Number 4, explain the effect that each thing has on air resistance. So, there are 3 things that affect air resistance, but one is not like the others. Okay? It's kind of like when you have to talk about all the political parties, but there's only 2 really that matter. Like, yeah, there's like 15, but like there's only 2 that we care about. There are 3 things that affect air resistance, but one of them is better than all the rest. Okay? So let's start with them in order with the different things. So explain the effect that each one has. So let's start with cross-sectional area, size. Okay? So first of all, size is inversely proportional. That means the smaller it is, it's directly proportional. So the less size, the less air resistance. So less size, less drag. Okay, and this one's kind of obvious, right? If there's less area, there's less particles rubbing on it. Right? There's less friction. So this is going to make and therefore, the larger the area, the more friction, the more air resistance there would be. The next one is drag coefficient, but if you say, so the technical term is cross-sectional area. If you say size, I'm on board with it. The technical term is drag coefficient. If you say shape, I'm on board with it. Okay? So this one is more aerodynamic, less drag. And again, for the same reason, there's less friction. But as I mentioned, one of these is not like the other. And the one that is not like the other is ding, 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 the heavyweight champion of the world, velocity. Velocity is the one that matters the most, like by a ton. These other things like help it, but this is the one that matters. And the reason why this is the one that matters is this is the one that changes. Because as you drop an object, it goes faster. As you drop an object, it very rarely changes its size. It very rarely changes its shape. It does always change its velocity. So velocity is the thing that matters most. And here's the effect. So less velocity is less drag. So the faster you go, the more air resistance. So if you go fast, you increase your air resistance. So if you want, again, if you want to go really, you want to have small air resistance, you need to have a small object that's very aerodynamic at low speeds. As it goes faster, the air resistance will build. Absolutely, it will build. Now, if it's aerodynamic and small, it'll build slowly. But as it goes faster, it will increase air resistance. Okay? So velocity is the big one that matters because it changes. And the reason why velocity matters, so why does velocity matter? Because as you go faster, you rub on more particles in the same amount of time, right? So if I go at 10 miles an hour in, let's do meters per second. If I go 10 meters per second, my object goes through 10 meters of air in 1 second. If I go 1 meter per second, I go through 1 meter of air in 1 second. So by going faster, I rub against more air particles, and that builds more friction. So the faster you go, the more friction there is. Okay? Got all... thing's all cattywampus. There we go. Okay. Any questions on that part there? Because this is right here the number one thing you should know. These are the things that affect air resistance. This is the most important one of all. And the reason they all do it is because of how much friction they create. Okay? All right. Let's jump to, let's take a break and watch a video. So I'm going to